Thank you. So my paper is titled Factors, Strategies and Criteria in Design Divergence. And the paper inquires into how design convergence takes place for students as they prepare for the delivery of their design output. My interest in the topic arose during the conduct of a project in a graduate design methods course. This is not a studio course, but a theory into practice type of course. The project topic was 2-in-1 handheld stick vacuum cleaners. The design process followed a problem-oriented approach, integrating various design methods for problem analysis, idea generation, and evaluation. In the first year of the project conduct, the decision-making activities of the students took my attention. Based on this interest, I conducted the same project in the following 2 years with the same design process. I gave the students of those 2 years a survey with open-ended questions in English on their acts of design convergence, following design divergence, through which they had generated numerous alternative sub-solutions for the stick vacuum cleaners. A total of 33 students attended the course in these 2 academic years. Looking at their background, they're all graduates of industrial design, and one was a mechanical engineer, with 31 students who were Turkish and 2 from other nationalities. Responses were collected for a total of 30 students who agreed to participate in the study. The research questions for my paper is: what are the acts of design convergence, and how does design convergence take place in reference to these acts? I conducted a literature review in order to formulate a framework for the study. Basically, I'm saying convergence, reducing the alternatives into one, is a function of the acts of critical assessment made with the consideration of many factors, design synthesis made through the integration of relevant information with detailed design representations, and decision-making made by matching solutions with the design problem, all requiring a decisive attitude that is based on well-informed judgments. Convergent thinking lies in the core of convergence and is best supported with methods and approaches that facilitate, but also control, both the generation through divergence and exploration through convergence of alternatives, and the compilation and processing of knowledge towards design synthesis. So this study investigates the involvement of the acts of convergence in the design process of the stick vacuum cleaner design project, carried out with graduate design students, with an attempt to explain how design convergence took place, at least for them. The design process, followed for all 3 years, was composed of 3 stages. The design process begins with problem analysis. The project briefing is made, the goal is set for product modifications, project dimensions are discussed, and students are asked to consider various issues such as the user, the use environment, usage, maintenance, and storage, etc. Following, students carry out product trials with numerous stick vacuum cleaners brought to class for function analysis and operational sequence analysis. This is followed by an analysis for quantified structure, where the interaction between the components is studied first in 2D as diagrams and then in 3D with simple mock-ups showing the configurations of the components in their correct proportions and rough forms. The process continues with idea generation using the morphological chart method. If you're familiar with this method asks for the design problem to be decomposed into around 8 to 12 sub-functions, which are placed in the rows of the morphological chart on the left-hand side. Then for each sub-function, 6 ideas for sub-solutions are generated in the cells of the row. Offering alternative sub-solutions for all the sub-functions yields a chart with numerous sub-solutions to pick from and combine into overall design solutions. Once the chart is completed as a team, students individually select sub-solutions for the sub-functions and combine them into overall design solutions. This calls for a 2-step convergence. The first step of convergence resulting in 6 alternative overall design solutions represented in 2D. With a break from design activities, a brainstorming session is carried out with the class to determine project objectives and then rank them in order of importance using an interaction matrix. In the second step of convergence, students reflect on their 6 alternatives and select one to develop into a final design solution. The students finalize their design individually and present a full-scale paper-based model. The process concludes with 2 rounds of evaluation. An expert opinion session is carried out with jury members for feedback. In the background, peers fill in a shared online document applying the searching for visual inconsistencies method. On this form, peers note visual and functional contradictions in the designs and make suggestions for improvement. This form is then accessible to the students who are expected to improve their design according to the feedback for the following week. On the final week, a quantitative peer evaluation is made based on the relative importance ratings for the project objectives determined altogether using the objectives weighting tree. Students score each design solution in reference to the rated objectives, and the accumulative scores display the appreciation given to the designs, opening up a final interactive discussion before the project is closed. For this study, the design process followed was reviewed for the acts of divergence and convergence, and a series of diamonds were identified on which 3 design iterations were based. The first takes place in the problem analysis stage, where product trials and the accompanying function and operational sequence analysis contribute to defining the problem space, followed by an exploration of 2D quantified structures to open up the solution space. The stage concludes with convergence, where students explore numerous 2D quantified structures and transfer a number of these into 3D mockups. The second takes place in the idea generation stage, with the divergence for the decomposition of the product into its subfunctions and design exploration for sub-solutions using the morphological chart. Students then carry out 2 steps of convergence, where they first combine sub-solutions into 6 overall alternatives and then transform these alternatives into one final design solution. The third takes place in the evaluation stage, with divergence through feedback given by the expert jury members and peers, providing new design references to students. Students are expected to consider this qualitative feedback while revising their final designs, again requiring convergence. The survey took place in both years with the aim of investigating the 2 steps of convergence taking place in the idea generation stage, where students narrowed down their design ideas first into 6 alternatives and then into one final solution. The survey was distributed to the students at the end of their model making activities for their final submission as a 2-page print form. The same 6 open-ended questions were posed in both years. The first 4 questions inquired the factors that affected the selection of sub-solutions to bring together into alternatives, how the sub-solutions were processed into these alternatives, the factors that affected the development of the final design solution, how the alternatives were processed into this final design solution, and the final 2 questions inquired the priorities of the student, which project dimensions did they consider in generating alternatives, which project objectives did they consider for the final design solution. The collected data was analyzed using thematic analysis and content analysis, with the findings collected under the themes, factors, strategies, and criteria. Factors were the issues that students considered for convergence. They were related to decision-making in particular. As a main consideration, the user was described as a single person living alone in a small flat, the student himself or herself, obviously, expecting practicality and ease of usage, speedy physical interaction, and healthier usage conditions through weight reduction and foldability. Positive user experience was a second major consideration, with easy-to-access controls, feedback mechanisms, understandable interfaces, and means to keep accessories together neatly during storage. The user environment was considered as different parts of the home with different surface types, levels of difficulty, heights, and dirt types. Likely problems were resolved with angular or curved stick structures for reaching difficult areas, and nozzle accessories and features that were multiple and different, or few and multifunctional, and that could detect and adapt to the changes of surface types, types of dirt, and amount. Design features were described as critical for an improved device performance and positive user experience. Students considered maneuverability of the stick vacuum cleaner, the manipulability of its components, having a self-standing structure, a consistent visual identity, and differentiation from or resemblance to the products available in the market depending on the student and their personal criteria. Students described concerns for developing solutions with a meaningful message and that solved problems rather than create ones. For this, it was seen that they determined goals or concepts or themes for themselves, which they used to generate, assess, and improve ideas, then bring them together into 6 overall alternatives in the first step of convergence. All students mentioned that they aimed to respond to the collectively determined project objectives for the final design solution in the second step of convergence. Strategies were the ways in which the students carried out convergence. They were related to design synthesis in particular. Students reported having selected the sub-solutions to bring together based on problem hierarchy, according to function priorities, according to suprafunctional qualities or personally set criteria and project objectives, based on personal preferences, or based on technical, functional, or visual qualities of the sub-functions. They used strategies for elimination. They eliminated sub-solutions that they found unrealistic or non-practical, and they also made assessment according to whether a sub-solution would fit an overall form as a design feature or not. Strategies for building configurations. While transforming the designs, students mentioned various strategies like grouping sub-solutions first, according to personally set criteria, studying interactions between sub-solutions and configuring accordingly, determining a main component and building other sub-solutions around it, combining each sub-solution with its neighboring component first and building the form on the way like a Lego, deciding on the overall form first, then deciding on where the component should be located on the body, grouping sub-solutions according to the main functions to which they relate, which is the stick vacuum and the handheld component, and then configuring the 2 ensembles into overall design solutions, determining 1 or 2 common features to all 6 alternatives and variating the remaining sub-solutions, and they checked and modified components for compatibility with each other as well as the overall configuration. 2 students indicated that they made no changes to the sub-solution designs and they combined directly. Students mentioned using methods in assessing sub-solutions, building the alternatives, and developing the final design solution. Among these were methods used in class for the project, like relative arrangements of components and interaction nets. They also indicated using scenarios for empathy building and design assessment, and having made online product reviews to check how features are used together. Tactics were the design moves that the students made during transformation. I identified 2 groups. One group of design tactics used in the first step of convergence. These were tactics for transformation, combination, addition, adaptation, modification, and negotiation. And in the second step of convergence, they used tactics for evaluation through diversification, differentiation, revision, and refinement. Criteria were the values that the students constructed for convergence. They were related to critical assessment in particular. Visual appeal was a criteria, aesthetics was a criteria in their selection. Functionality was a criteria related to suitability of purpose of the components and practicality of the overall device. Product performance related to the effectiveness of components and efficiency of overall device. They tried to address specifications and they determined must-have features that they used as criteria. They strived for distinctiveness in the alternatives. There were students who strived for simplicity, avoiding visual and functional complexity. And realizability was a criteria, transformability of ideas into overall design solutions. So which ideas can I transform as I make my design suggestions was a criteria. And feasibility, the development of ideas to make them realizable in terms of production, again, was a criteria. This paper presented a study with graduate design students that attempted to explain design convergence. So design convergence takes place in reference to the acts of decision-making, design synthesis, and critical assessment through the involvement of various factors, strategies, and criteria as mechanisms of convergence. Factors are the considerations behind the design decisions made and provide with directives for informed design moves. Strategies are the ways in which design synthesis is carried out, and following them leads to design transformations as combinations of design moves plus knowledge integration. And criteria are the values strive to attain or make judgment against during critical assessment, and adopting them allows to situate and contextualize the design transformations. These mechanisms have been identified from responses to a survey carried out among the students who had approached the end of a rigorous design process for a familiar and non-specialist product. It can be argued that these mechanisms came into action during design convergence because the problem area was familiar to the students to begin with, and the problem frame was established with relevant information and well-defined limits. Also, the design process was planned step by step, making it easier for the students to apply acts of convergence and recognize and describe them upon reflection. These mechanisms of design convergence were facilitated with certain provisions. Following a methodological approach in the project conduct made it easier for students to make design moves in each step. Students knew that the outcome for a particular step would be related to the design task to be carried out in the following step. This is explained in the literature as task interdependence. Working interactively also supported the students in making timely decisions and set bars for an optimum level of quality in the submissions. Being prepared for convergence with the necessary skills, experiences, quality of information, and quantity of ideas were also found influential. Product trials were useful in empathy building. Studies for quantified structures allowed students to simultaneously explore external form and internal component arrangements. The morphological chart formed an expanded solution space with options for the students to choose from. Working with mock-ups and models supported design exploration and allowed students to act out with gestures. With backgrounds in design and engineering, students had judgmental awareness, were familiar with evaluation, and experienced in giving and receiving criticisms. All these were helpful in decision-making, design synthesis, and critical assessment. So this concludes my presentation. I hope the study was of interest to you. Thank you very much.